14 grinding machines, one centralized system. I am sure you will be intrigued. Stay tuned. I'm really glad that you are watching this video because I'm really excited to tell you about this system. This massive system behind me is a centralized grinding oil filtration system which will be catering to needs of 14 tool and cutter grinding machines, which will process carbide as well as HSS tools. This massive system is going to be installed in Pune at one of the major cutting tool manufacturers. This system is divided into three parts. I'll explain those parts one by one. Overall, apart from serving to 14 grinding machines, the overall capacity of this system is 1400 liters per minute. It will hold close to 5000 liters of grinding oil. So Transor India has taken a huge responsibility on itself. This entire setup over here is the pre-filter of the system. All the grinding oil from grinding machines will come through these. It will be distributed. The flow will be distributed in these magnetic separators. Now, the impurity that is going to be there in the grinding oil is the high-speed steel HSS along with carbide. Now, later on in the system, we don't want HSS and carbide to mix. Hence, all efforts are made to remove the HSS at this stage itself. The reason being, carbide has a higher resale value. So whatever carbide we will recover later will have a higher scrap value. So these are three heavy duty magnetic separators. The gauge level for these magnets is around 4500 gauge. These are rare earth magnets that we have used over here. It is a plain drum and squeezer roller type magnetic separators. So the initial flow will be distributed amongst these magnetic separators. Once the heavy or the initial coarse particles of HSS are trapped by these magnetic separators, the oil will be collected in this conveyor. Now, this conveyor acts like a sedimentation tank. So whatever dirt is there in the grinding oil will allow it to settle in the conveyor, and semi-clean oil will overflow from the conveyor to the main system. The timing of this conveyor is so set so that whatever dirt that comes out from the conveyor has minimum oil in it, so that not a single drop of grinding oil is wasted. The first conveyor that I just showed you is the pre-filter for the grinding oil. The pre-filtered grinding oil will overflow from that conveyor to this tank. This tank is divided into compartments, dirty and clean. Once the pre-filtered oil enters the dirty oil compartment, the level inside the tank will increase, which will be sensed by the level sensors. And at a preset level, these filter pumps will start. These pumps will supply the pre-filtered but let's say semi-clean grinding oil to the filter vessels. Now the filter vessels we have divided into, there are total 16 filter vessels divided into groups of 2. So there are in total 8 groups of filter vessels. Everything is automated. The flow of grinding oil through the filter vessels is controlled using the actuated ball valves, and the clean oil coming out of the filter vessels will be collected in the clean oil compartment. Now once the level inside the clean oil compartment increases, the clean oil pumps will start. Now we have provided 3 clean oil pumps. Not necessarily all 3 pumps will start at the same time. So it is sort of a automation again. Since this unit is going to be connected to 14 grinding machines, there can be a scenario when certain machines are not in operation. So at that time, the total flow is not required to be supplied. So in that case, some of the either one or two of the pumps will stop, and as and when the requirement increases, the pumps will start again. Now, as we know, maintaining the temperature of the grinding oil is very essential for cutting tool manufacturers. The location where we are going to install this system has a cooling tower, so it can provide chilling water. Hence, instead of providing a big chilling unit, we have provided a plate heat exchanger. So on one side, through this pump, the clean oil will be pumped through this plate heat exchanger. So that becomes the hot side of the plate heat exchanger. And the cooling water from the chilling tower from customer's location will come on the other side. So that becomes the cool side. And the heat transfer will happen inside this, and clean temperature control, or rather cool oil, will be again collected in the clean oil compartment. And that temperature controlled cool oil will be supplied to the machines. Now let us check out the automation, or how the grinding oil will flow through each individual group. Grinding oil, the semi-clean grinding oil coming from the filter pump will enter the filter vessel groups through this valve. This is the dirty inlet valve. The oil will travel through the filter vessel, which contains the filter element, and the filtered clean oil will come out from that valve. This is the normal filtration cycle. Tranzor India systems, the elements that we use, those are not use and throw. We regenerate the filter elements by backwashing it. Backwashing happens with the help of compressed air. So now let me explain how the backwashing sequence will work. During backwashing cycle, the inlet valve will close. Similarly, the clean outlet valve will also close. So now there is no grinding oil coming inside the vessel, but the vessel is filled with oil. Before we do the backwashing, the vessels need to be empty. So we pass compressed air through the stomach of the vessel and drain out all the grinding oil inside the vessel through this valve. Now once the vessel is empty, what we have inside the vessel are filter elements with carbide and HSS dirt on it, and we want to remove that. In order to remove that, we use these valves. So these valves will open, and compressed air at about 5 bar pressure will enter from the top of the filter vessel, and it will enter the filter elements, which are hollow. Because as the compressed air enters the filter elements, it will sort of dislodge the dirt trapped by the filter elements, and it will fall down inside the vessel. And again, because of the compressed air pressure through this valve, the dislodged carbide or HSS along with some oil will flow to the recovery conveyor. As each filter group backwashes, the carbide and HSS dirt that is dislodged during the backwash process, along with the oil, it enters the recovery conveyor. Now, oil from each group will enter the conveyor at its own sequence and frequency. So, the function of this conveyor is, one, to remove the carbide that comes inside the conveyor, and second, to return back the grinding oil that comes inside the conveyor back in the system. So not a single drop of grinding oil is wasted through our system. Now the grinding oil that comes inside the conveyor is pumped using this pump, and we have a separate group of filter vessel having the same filter elements, and whatever dirty oil that goes in the filter vessel is filtered through the filter elements, and the clean output from that group is collected in the dirty oil compartment of the system. So that oil again enters the system and the same process follows. Now the timing of this conveyor is set, so it is settable, but we also set it during our installation process. It is set so that the carbide that comes out of this conveyor is almost dry. It is not completely dry. It will have some percentage of oil, but through the timing of the conveyor, we make sure that oil is not wasted in the recovery process. And whatever we get at the output of this conveyor is almost 90% carbide. I hope you enjoyed watching the video. I certainly like presenting the system. Please mention your comments regarding the system or regarding the video. And if you like this video, please subscribe to our channel, ThinkFilter. Thank you.